So the first lesson will be talking a little bit about function notation. And function notation, you'll see something that looks like this, f for function. And the way you'd say this would be f of x, the function with relation to x, anything like that. But you can basically think of the function with respect to x as y, or that's what we can you go get that, please? And when we're doing these, we could have like a y equals 3x plus 2. So if I wrote f of x equals 3x plus 2, it would imply the same thing, okay? All right, so we have inputs and outputs. And when I have something like this, so if I have f of 1, what this means is I plug 1 in for x. So like that. And 3 times 1 is 3, right? Plus 2 would be 5. So the way you'd express this answer would be f of 1 equals 5. So I input 1 and my output is 5. Okay? You can think of these as independent and dependent variables. Your independent variable will be in here. It'll be on the x-axis when you see it graphed. So if I have something graphed like this, and I just have a series of random squiggles there, you can test if this is a function because each x value can only have one y value that goes with it. Meaning, if I look in here and I give, I say this is 3, and that's 5 or something. If I go up to 3 right there, the only y value that is on that function right there is there at 5. But if I drew this differently, let's say I have this right here, and I have my x value at 3 right here. If I go up, I have a y value here, and let's pretend that's 5. Well, here's the problem. I have another y value that goes with that x value, see? Let's pretend that's negative 5. So in other words, this can't be a function because this x value has 2 potential outputs. So it's like if I have a machine, if I turn on that television and I go to channel 3, I should get channel 3 all the time. I should get whatever that channel is broadcast as. But if I go to channel 3 and I get a different channel all of a sudden it's assigned value, something is broken. Thus, it's not a function. So if it has 2 potential outputs, that machine's not consistent, so it's broken. Okay, I could look at that in table form as well. So let's say I have x and y. And let's say I have -1, 0, 1, and 1. So these are numbers I'm putting into my function and seeing what comes out. So let's say I have 5, 6, 7, and 8. Well, here's the problem. I put in 1 and I get 7. I put in 1 again and then I get 8. If I put in 1 twice, I should get the same number each time so that it's consistent. Okay, so this would not be a function. This would not be a function. Obviously, this would, because at all times, no matter what, there's only one y value, or there's only one y value that comes out of each x value. All right, so that's a brief primer on what we're doing today. We also have domain and range. Domain will be the set of x values in a function. And range will be the set of y values in a function. So if I do this, let's say I have a quadratic here, and I do my domain and range. My domain, well, the x values all the way to the left, see how this would continue going upward and to the left forever, right? So I would have negative infinity to 0. So the left side all works because my domain's my set of x values. So we're talking about left and right. And as I go up and to the right, that would go up and to the right forever. So I would have all the way from negative infinity to positive infinity. And the way you can say that, so if I have from negative infinity to positive infinity on the x values, the way we can say that is saying all real numbers, which, because mathematicians are lazy, they give that as a symbol, and it's this like fancy looking R that I can't do very well. But if you write a capital R, I'll know that you mean all real numbers. Okay, we have range now. So is there are any y values working down here? No. So they all start here at 0. And then they go up forever. So the way I can say this is that y is greater than or equal to 0, because y has to be bigger than 0. But it can be equal to, since it does touch right there.